Hi, I am Kyle from the University of Pittsburgh. I am presenting the work of me and my co-authors, Sina, Lorraine, and Adriana, titled Incorporating Geo-Diverse Knowledge into Prompting for Increased Geographical Robustness in Object Recognition. One challenging domain shift that plagues computer vision models is geographical shift. A change in geography, such as in country or city, can cause object appearance differences between training and test settings. Example object design and context changes are shown here with unique bed materials and unique house architectures. These changes can occur due to factors like culture, climate, and economics, and overall the problem has been very understudied. There is currently a lack of suitable techniques for addressing this problem. The crux of our work is the hypothesis that these domain shifts can be addressed with descriptive knowledge of the way objects can shift. In particular, we explore how to improve the context of text class representations and prompts in vision language modeling. We first aim to investigate whether the context of country names changes the performance of object recognition. Second, we aim to test if large language models can be used as an auxiliary source of knowledge to add important object context to improve alignment. We reason that LLM context can include materials, designs, and context that can be useful for categorizing objects, such as shown in this example with tools. We find that the use of country names and geospecific LLM knowledge, especially together, can improve recognition versus default clip prompts, as well as a general LLM baseline where we prompt an LLM for object knowledge independent of geography. Gains are most prevalent for Africa and Asia, suggesting that default prompts may be less aligned to these regions than to Europe and the Americas. A high prevalence of Europe and Americas data in training can also explain greater default prompt alignment. We further propose a mechanism to better consider geodiversity when data is limited to an easy-to-access source region, for example, Europe. In particular, we propose to learn soft text prompts on source data, for example, from Europe, while regularizing the class text representations to be consistent with target geographical knowledge, for example, from other regions like in Americas, Asia, and Africa. Here's our mechanism. First, learnable soft prompts are defined. They're shared for each class. Second, a cross-entropy loss is used to train these prompts using some supervised image data. Third, we define geospecific knowledge as the class representation for a given geography. The average embedding of all geo-based LLM descriptions for a class is used. Fourth, using a set G of regions, knowledge is ensembled to create a regularization target embedding. 5, we define an auxiliary loss that enforces a cosine distance constraint between ensemble geo knowledge and the learned class embeddings. The overall loss with this geo-knowledge regularization is shown here. In evaluating this method, we find that we can improve balance accuracy across target geographical regions versus recent soft prompt baselines on 2 different data sets. This is without using any target image data in training. The top improvements come with the country in prompt plus LLM combined setting. We explore the classes considered difficult for default soft prompting, as demonstrated in co-op. Our method helps especially on ones with low performance, shown in plus 8.7 gains for the less than 40% recall category. We also compare our regularization to directly training on a few shots of target data. A 16-shot regularized model trained on only source data outperforms models trained on 12 shots of target data for Dollar Street and 4 shots of target data for GeoNet. Some example LLM descriptions we use are shown here, as well as which descriptions most highly activate for CLIP. The capturing of attributes like stucco and wooden are shown, though due to imperfect vision language alignment, there can be errors, as shown in the rug example. To evaluate LLM knowledge, we use UMAP visualization of the average text embeddings across descriptors for various categories. Shown here is the example for homes, and it roughly clusters embeddings by continent, which is an intuitive behavior. To conclude, we bring attention to how various strategies to prompt click affect geographical robustness. We also present a mechanism that can be used to achieve a more generalizable set of class representations. Much future work is needed, though, as VLM and LLM knowledge is likely not adequate for all regions. Thank you for listening, and please reach out with any comments.